Today we will be finding the volume of different prisms, cylinders, cones, and pyramids. So our volume formulas for each of these three-dimensional figures. For the prism, we'll be using V equals BH. So capital B stands for area of the base, and then H is height. So depending on the base of the prism, our formula for finding the area of that base could be different. So for this figure here on the left, if we say the base would be this bottom rectangle, and similarly the top would be the same, but the area of the bottom down here would just be base times height, and then we'd multiply it by how tall the prism is. And then for the triangular prism over here, the bases are the triangles, so we would have to find the area of this triangle using 1/2 base times height, and then multiply by how tall the prism would be if it was standing upright. So formula overall is just volume equals area of the base times the height for a prism. For a cylinder, formula is the same. So V equals area of the base times the height. In this case, the base is a circle, so you'll also see this written as a V equals pi r squared times the height. For a cone, our formula is V equals 1/3 times the area of the base times the height. And again, the base here for a cone is a circle, so we can change the formula to say 1/3 times pi r squared h. And for a pyramid, volume is equal to 1/3 area of the base times the height. So the area of the base depends on what polygon we have for the base of the pyramid. Let's take a look at a few of our examples. For our first problem here we'll be using V equals area of the base times the height. So the area of the base here, the base is this rectangle down here at the bottom. So to find the area of that, we'll take 24 times 20. And so that gives us an area of 480. So this is not the answer, I just need that number. The height of the prism is over here, and it's going to be 10. So I need that number as well. So to find the volume, we take the area of the base times the height, so 480 times 10. That gives us 4,800, and then if we use the correct units here, it's going to be centimeters cubed. For question number 2, the prism is oriented a little bit differently. It's not laying on one of the bases. So remember, for a prism, the two bases are parallel, and then the faces are made up of rectangles. So that means here your base is the triangle. So the formula is volume equals area of the base times the height. The base here is a triangle, so we're going to have to use 1/2 base times height. If I redraw this triangle here, notice based on the markings that all of the sides end up being 8. So if it's an equilateral triangle, these angles end up also all being 60 degrees. So to find the area, I need to know the height. So this is kind of back to our area of polygon problems. As I solve this here, we'll have that the base is 8, but the height is going to be found here using trig. So again, just like it was before, this is going to be tan, and it ends up being tan of 60 degrees is going to equal h, the opposite side, over the adjacent side, which is going to be 4, because I'm only using the right triangle, so only care about half of that. If I solve this trig equation for h, I'd have 4 tan 60 equals h. So I'll plug that in down here. And now I can multiply this out to get the area of the base. So this ends up being 27.7. So that's just the area of the base. The height for this one, so think about if you were to sort of turn this prism and sit it upright. If it was sitting on the base here, the height would be 10. So our height's 10. That means when we go to substitute into our volume formula, we'll have 27.7 times 10, and that's 277 inches cubed. This third problem, it's similar to the previous one. The base is a triangle. So when we go to find our volume here, got to find the area of that base first. So for that triangle, since it's a right triangle, we won't have to use trig. I just get to do 1/2 base times height, so 1/2 6 times 10. That's 30. And then the height of the prism will end up being 5. So the volume will equal 30 times 5, and that gives us 150 meters cubed. For the fourth example, we've got a cylinder. So for the cylinder, volume is still the same formula. So we'll have area of the base times the height. In this case, the base is a circle. So we'll have to find pi times r squared. So pi times 3 squared is 9 pi. Now I'm going to leave it like this. I'll multiply it out on the last step. And then the height ends up being 8. So my volume is area of the base, which is 9 pi, times 8. So that's 72 pi, or you could just type this all in the calculator at once and get a decimal that's approximately 226.1 centimeters cubed. For example number 5, we've got another cylinder. And notice this would be like an oblique cylinder. It's sort of tilted off to the side. The formula is still area of the base times the height. And the base is obviously a circle. So we'll have pi times the radius. Now the 2 right here, this is showing you that the diameter is 2, so our radius would be 1. And 1 squared is 1, pi times 1 is just pi. So if you want to use 3.14, that's fine. I'm just going to leave it as the pi symbol. The height right here, keep in mind, height has to be perpendicular to the base. So even though this 3 is sort of drawn off to the side, it's the number I need because it's perpendicular. So our height is 3. And then plugging into our formula, we have volume equals pi times 3, which is 3 pi. Or you could type it into the calculator and get approximately 9.42 cubic meters. For problem number 6 here, we've got a pyramid. So the formula for a pyramid is 1/3 times the area of the base times the height. So here your base is a square, and the area would be just 6 times 6, so 36. And the height is 8. So my volume will be 1/3 times 36 times 8, and that is 96 cubic inches. When it comes to the calculator and you want to type 1/3 in, so this is specifically for the graphing calculator, you will just type 1 divided by 3, and then you either do times or you can use parentheses. But fractions go in as division problems. So moving along here to number 7. 7 is another pyramid, but you'll notice this time the base is a hexagon. So now we got to go back to what we learned about finding the area of polygons. So the formula is going to be 1/3 times the area of the base times the height. So when we found areas of polygons, we would break it up into a bunch of triangles. So I would come over here to the hexagon, and I have 6 triangles in here that are all the same. So I need to find the area of one of those triangles and then multiply it by 6. So to find the area of one of them. So we know that the base is 8, and we know that all these angles are 60. So remember, the way we would get this is you'd find this angle up here first. 360 divided by 6 gives you 60, and then you can figure out what's left for the other 2. But ultimately what I need is to know the height of this triangle. So we're going to have to go back to trig, and this is exactly the same as the triangle we had in problem number 2. So I'm going to use tan again to find the height. So it'll be tan of 60 degrees equals opposite over adjacent, and to solve we'll have 4 times tan, 60 equaling the height. So as I go through here and write out my formula, I need to take 1/2. The entire base is 8. The height is 4 tan 60. So multiply this out, and you get 27.7. Now that's the area of just one of the triangles. I need to multiply it by 6 because it is a hexagon, and that gives me 166.2. Okay, so this is not the final answer. That's just the area of the base. Then I have to multiply that by the height, and the height is 10. So just so I have some more room, I'm going to continue over here. So the volume would be 1/3 times the area of the base, which is 166.2, times 10. And that gives us 554 cubic centimeters. And the last one, we got our cone. So for a cone, still 1/3 area of the base times the height. The base is a circle though, so we'll use pi r squared. So pi times 1 squared, that's just pi. And then the height is 3. So our volume will be 1/3 times pi times 3. And that gives you approximately 3.14.